Hi there. It's good to share this quiet with you. In the gentle dim, your shoulders loosen and your breath finds its easy rhythm. Slow in, soft out. Nothing presses tonight. Just a calm room, a warm voice, and the small comfort of being unhurried. Tonight, we turn our lantern toward a world that hides in plain sight. Venus, the evening star, bright as a promise, secret as a closed book. We'll drift above its pearly clouds and listen to the winds that circle the planet in days, while the surface turns so slowly it almost feels like a held breath. We'll trace old rumors of oceans, follow the whisper of volcanoes, and let radar maps reveal the landscape the eye can't see. No rush. We'll move like moonlight across a floor, step by quiet step, until the hidden world feels a little less distant, a little more known. If this gentle journey brings you ease, a soft like and a quiet subscribe, help others find their way here too, only when it feels right. For now, let your breath lengthen, your thoughts grow light, and your mind settle like dust in a sunbeam. Close your eyes. Venus is waiting, and we'll begin together. Venus is often called Earth's sister, born from the same drifting cradle of dust and gas, circling the same sun in a quiet lane of space. On paper, it should feel familiar, nearly the same size, made of the same stubborn rock and metal, close enough to our orbit to share the sun's wide comfort. Yet the sibling we expected to recognize wears a different face entirely. From our nightside shore, Venus blazes like a polished gem. It outshines every star, second only to the moon, bright enough to tug at the eye even when the world is still blue with day. That radiance once seeded stories of goddesses and love, of omens and returns. But the brightness is a mask, a silver veil hiding a world that leans into the far edge of possibility. Where our planet cools its skin with oceans, Venus stretches broad plains of basalt. Where our sky lifts light and blue, Venus keeps a heavy cloak of carbon dioxide and clouds laced with sulfuric acid. Where our winds and rains take turns that nurture, Venus whips superheated air around the planet at hurricane pace, while the heat below never loosens its grip. Questions have clung to that light for centuries like moths at a window. Could life ever have found a foothold there? Did Venus once cradle oceans that later boiled away as heat ran forward and never came back? Do volcanoes still breathe under those clouds, writing new land in the dark? Curiosity bridged the distance. Landers dropped through the haze and pressed their metal palms to hot stones for a few brave minutes. Radar from high orbit combed the surface and returned rough portraits of mountains, impact scars, and endless flows. Each mission was a small candle in a storm, and together they sketched a world both intimate and unreachable. Venus stands close enough to show us something about ourselves, to mirror what can happen when a climate tips and balance slips from its perch. Some scientists picture an early Venus, gentler than now, air thinner, water gathered in places, a world not hostile but undecided. Our story bent one way, Venus bent another, sealing in its own heat until the furnace became a fate. Even so, it is not only the extremes that hold us. There is a quiet poetry in its slow, backward spin, in the way its clouds flow like a river wrapped around the globe, in its role as the brightest wanderer of familiar evenings. A gentle step into the origin makes the contrast feel less like a surprise and more like a fork in a path. Before names, before myths, the young solar system was a busy nursery, its floor a swirl of pebbles, ice, and powder, drifting and bunching under gravity's patient hand. Planets did not appear like finished beads on a necklace. They grew from collisions, from rubble, slowly persuaded into spheres. Imagine not a tidy classroom of worlds, but a construction site at dusk. Sparks, noise, the smell of hot metal, chunks the size of cities slammed together, melted, and flung glowing spray into the dark. Some pieces were swallowed by growing planets. Some were thrown outward to become vagrants in the cold. The violence lasted for ages, loud and necessary, the background hum of making anything durable in space. From that rough mill, two near twins emerged, rocky, iron-hearted, crusts cooling from oceans of lava into solid plates. Silicon and oxygen knitted the first hard skins. Iron sank to the center and made steady cores. They ended up almost the same size Earth, a touch larger, Venus only a breath behind, close enough that models held in both hands would be hard to tell apart. Density, too, that compactness of matter, stayed in step. Side by side on a cosmic scale, they would balance almost evenly. The resemblance is not a trick. It is written in numbers that repeat: diameter, mass, composition. Siblings by any honest measure, even if the elder's face turned out gentler over time. Their birthplaces helped write that kinship. Both formed inside the sun's broad band, where liquid water can exist on a surface far enough from the furnace to avoid constant boil, close enough to keep ice from locking everything in glass. Venus circled a bit nearer, Earth a little farther out. Differences so small they sound like footnotes later became center stage. In those early years, ingredients rained down from the dark: water, carbon, nitrogen, the seeds that chemistry loves to move around. Asteroids and comets were messengers, both destructive and generous. Picture an icy wanderer striking the young Venus, erupting steam and fragments, leaving behind water that later could pool and whisper. We cannot yet weigh exactly how much water came, but the hints say enough, maybe even enough to lace the lowlands with seas. If that memory is true, then the image of Venus as only a dry furnace is a snapshot, not the whole album. Family resemblances exist across the inner planets, each with its own temperament. Mars sits smaller and cooler, a cousin who grew thin and quiet. Mercury is the stripped-down relative, an iron bell swinging too close to the sun's heat. Among them, Venus is the sibling that feels the most like us when reduced to essentials. The danger in that closeness is simple. We may expect repetition where the universe prefers variation. A few million kilometers closer to the sun does not sound like an argument for catastrophe, but systems built on feedbacks become particular about small nudges. The difference between a cozy greenhouse and a runaway greenhouse is not a wide valley. It is a narrow walkway along a cliff. Crosswinds matter. Hold the picture of both worlds passing through their hot adolescence. Surfaces glowed, then cooled. Volcanic breath thickened the air: carbon dioxide, nitrogen, a trace of water vapor, sulfur, stitched in like a sharp smell. As crusts hardened and mountain roots explored depth, the two planets could have looked remarkably alike from a distance. Two almost equals in size and promise, spinning under the same sun. That closeness seeped into culture long before science measured it. People watched Venus return night after night and gave it roles in their stories. Through the bare eye, it can mislead a little. It looks like a star, but it is steadier, rounder, too bright. That brightness is a gift from its clouds, thick, pale, and reflective, a giant mirror turning sunlight back outward. Mercury sits closer to the sun but wears little. Mars comes nearer to us sometimes, but is rusty and thin. Venus dresses in a brilliant coat, and so commands attention. From the ground, there is a pattern to how it visits. You won't find it high and midnight blue above your head. It prefers the edges of day. It lingers in the west after sunset, easing the sky into night, or rises ahead of the dawn in the east, a herald with a white flame. That dual life earned it two names, Evening Star and Morning Star, titles that made sense long before anyone knew it was the same object playing both roles. The rhythm follows a simple dance. Venus loops around the sun in about 225 Earth days. From our moving point of view, sometimes it trails the sun and shows up at dawn. Sometimes it runs ahead and glows at dusk. Its brilliance lets it be the first to puncture twilight and the last point to fade when day takes hold. Eyes from long ago watched, counted, and kept track. Priests and scholars in baked brick cities traced its comings and goings, marked them on clay, and tied them to seasons, rituals, and the strange turning of fortune. Elsewhere, navigators took it as a friend to steer by, and storytellers folded it into the long cloth of origin and return. Look more closely through a small telescope and the planet blushes with a secret. It shows phases, crescents, and gibbous shapes like the moon. When it sweeps around the far side of the sun, it looks nearly full. When it comes near, it thins into a delicate slice. The light has always been a matter of geometry, but seeing that geometry unfold in your own backyard changes the feeling. The phase is quiet proof that Venus is a globe, reflecting sunlight from its curved face, bridging imagination and simple fact. The brightness pulls, but the hidden side of that mirror holds the other half of the tale. Beneath the clouds, the air grows crushing and hot. Carbon dioxide stacks heavy upon itself. The pressure at the ground would flatten a human visitor and make metals sweat. The clouds above are not cotton. They are droplets of sulfuric acid wrapped around tiny grains that drift and settle. Winds up high race round and round the planet in a few days, hauling the cloud tops with them. The surface below turns so slowly that the sun seems to creep, and the planet's spin is backward compared to ours. Lava plains spread like frozen seas. Impact craters dot the land where big stones pushed through the veil and scalded the ground. Mountains rise with old effort, Aphrodite Terra, Ishtar Terra, names that echo the stories told under different stars but for the same shimmering light. These are not details to frighten, only to marvel at. A world made by the same tools as ours. Rock, heat, gravity, yet arranged into a different melody. Somewhere early on, a handful of small differences found one another and linked arms. Perhaps Venus held on to its thick carbon dioxide, while our world began to lock some of its own into rock and water. Perhaps oceans there were shallow and vulnerable, warmed by a sun a little more insistent. In a feedback loop, heat frees more heat. Water vapor, a powerful blanket, pulls more warmth into the air. Warmth encourages more water to rise. The process feeds itself until escape becomes hard. On Earth, temperature and oceans settled into a duet that allowed rain to fall and rivers to carve, plate tectonics to breathe carbon in and out of stone. On Venus, the duet faltered and turned into a drumbeat that never softened. The greenhouse ran away with the song. The difference between enough and too much revealed itself as a razor quietly waiting. That razor shows us something about how narrow the road can be for a surface like ours to stay calm for long ages. The lesson is not scolding. It is simply clear. Climate is a balance with many moving parts, and nearby worlds remind us how those parts can stack in other configurations. This is why scientists still reach for Venus with instruments and hopes. Landers once pressed through the clouds and survived in the heat for a short breath of time, enough to send a picture and a handful of measurements before they fell silent like stones cooling in a kiln. Later, radar from orbit drew maps surprisingly detailed for something touched only by radio waves, revealing long flows of rock and patterns that might whisper "volcano" in a careful ear. The possibility that volcanoes still sigh there is not wild. Young rock is visible in places, and the air's chemistry hints at change, though proof is a shy creature under that thick sky. Hold, too, the idea that oceans may have once folded themselves across low basins there. If water shimmered on early Venus, even briefly by geologic standards, then the planet carries memory, not just of fire, but of reflection, light on ripples, clouds forming, rain falling. The thought tells us nothing irresponsible. It simply widens the picture and gives the furnace a pass that contains softer weather. Comets are the usual couriers in that picture, their ice cracking and boiling on impact, their cargo of water joining what the planet already had. Our world likely received the same deliveries, and out of those messy, loud beginnings, both planets could have written lakes and seas on their surfaces. To call Venus a twin is to accept the full strangeness of family. Siblings can share a face and choose different lives. You can love the similarities and respect the differences. On one world, the sky thins to blue and sings with birds. On the other, it thickens to white and hums with heat. On one world, rain carves rivers and the sea keeps time with the moon. On the other, droplets of acid drift and evaporate before reaching the ground. Yet the bones are the same rock that fractures, metal that flows when pushed, gravity that pulls with familiar strength. Lift both planets in your mind and feel how nearly equal they are in heft, how closely matched in size. The numbers are not just statistics, they are the quiet architecture of the comparison. Look up on a clear evening when the sun has slipped under the horizon and the air is cooling against your skin. That bright pin that refuses to twinkle is the sister. It can cast a shadow if the night is moonless and the air is steady. With a little practice, you can sometimes find it in daylight, a small white bead in a pale field. You might be tempted to mistake it for a plane. It is steady enough, bright enough to trick the eye. A small telescope will show its crescent shape and might make you catch your breath, a tiny sickle of light hanging alone. That quiet, graceful curve is the simplest proof that we live in a system of moving worlds, each reflecting the same sun from different angles. Ancient eyes noticed all of this in their own way. In river cities, where reeds pressed script into wet clay, the planet was charted and given a temperament, gentle at dusk, fierce at dawn, its twin roles braided into ideas of love and war, abundance and upheaval. The Maya folded its depths into calendars with astonishing precision. Across oceans, navigators and storytellers leaned on its steadiness as guide and sign. What we hold now is a richer picture, but the feeling endures. Venus is a reflection and a warning. Two worlds can start alike and drift apart through quiet chains of cause, not miracle. Even so, it offers beauty inside its harshness, cloud belts like silk, a slow backward spin that turns a day into a long sigh. a brightness stitched into countless evenings. Follow that light with your eyes toward the thought of what lies beneath, and the mind grows gently still. The universe keeps more than one way to be a planet. The same notes can make another song. From there, the rhythm carries on. Venus returns and returns, lantern of morning, jewel of evening, keeping a clock older than memory and fresh each time it rises. Generations set small rituals by its glow. Farmers glancing east at first light. Sailors trusting that bright companion near the horizon. Lovers finding meaning in that unwavering spark. Poets borrowing its shine when words thinned. Even now, with screens in our hands, the same light lifts our gaze and reminds the body that the sky is still here, vast, patient, and quietly keeping us company. What the myths wrapped in story, the eye still feels in a simpler way. Venus pulls attention upward and softens breath, not with argument but with shine. It cuts through errands and thoughts, and for a moment, the mind steps out into wider air. The universe is not distant in those moments. It is as near as a bright point that refuses to twinkle. Long before telescopes and equations, people noticed this and stood in the same hush you can find now. Twilight is the easiest time to join that lineage. Step outside as the day exhales its last light and look west, or rise early and look east before the first birds test the morning. The most steadfast brightness you see low over the horizon will almost certainly be Venus. In that small act, you're sharing a habit older than cities and ink, older than most of what we call history. The same point once guided canoes across dark water, slipped into prayers, and tugged questions loose that science still unfolds with careful hands. The bright wanderer stitches past to present, myth to method, wonder to understanding. That bridge is worth crossing slowly. If you could follow the light down into the planet that makes it, you'd feel the story change, soft radiance, giving way to weight and fire. From orbit, Venus looks quiet, wrapped in smooth whites and pale yellows, a pearl without markings. Beneath that calm, the air grows thick and sour, carbon dioxide, almost to completion, over 96%, seasoned with nitrogen and traces of harsher things. Descend, and sunlight grows dim and strange, scattered to an amber dusk that never lifts. Droplets of sulfuric acid hang in layers like cold smoke. By the time your path reaches ground, the pressure squeezes with 90 times the weight you feel at sea level on Earth, and the heat settles past 460 degrees Celsius, a furnace steady enough to melt lead and the patience of any machine. It is not a world that throws you aside. It is a world that holds you too tightly, a slow, irresistible embrace from every direction. The air itself is the answer to most of the riddle. Carbon dioxide does not simply visit here, it rules. On our planet, it is a faint spice, measured in parts per million, crucial but rare. On Venus, it fills the sky, trapping warmth the way thick blankets trap body heat. That alone draws a sharp line between the two worlds. One keeps a temperate memory of sunlight. The other keeps the sun's heat like a vow. Clouds add their own twist. Droplets form from chemical reactions high above and from volcanic gifts, and together they make a mirror so bright it returns sunlight with ease, which is why Venus glows so fiercely from far away. But the mirror hides a second blanket beneath a thermal trap that lets light in, then will not let heat leave. Picture a car parked in full sun. Light pours through the glass, the seats drink it in, and the warmth rises until the air inside becomes too hot to touch. Now replace the car with a planet, the windows with clouds, and the dashboard with rock. Energy arrives. The ground absorbs. Infrared heat tries to leave and is caught by carbon dioxide again and again, bounced and held until the whole world settles into a sweltering balance. Feedbacks deepen that balance into fate. There was likely water once, perhaps pools, perhaps seas, and water vapor itself is a powerful greenhouse gas. As warmth climbed, more water evaporated, which trapped more heat, which pulled still more water into the air. The loop fed itself, and with time the surface reservoirs vanished into space or into reactions that never gave them back as liquid. Without oceans to sip carbon dioxide and turn it into stone the way Earth's does, the gas piled higher. The planet lost its simplest break. It helps to remember how Earth sidestepped that trap, at least so far. Distance played a role. A little farther from the sun, our surface could keep liquid water for eons. Those oceans became a regulator, dissolving carbon dioxide and storing it as carbonates in seafloor rock. Life joined the dance, microbes and plants cycling carbon and exhaling oxygen, shifting the air's flavor in ways that gentled the climate. Plate tectonics moved the story along, bringing carbon up through volcanoes and drawing it down through weathering and burial. A long inhale and exhale that kept levels from racing away. Venus seems to lack that steady conveyor. Its crust does not shuffle and trade in the same way. Once the tilt toward heat began, nothing pulled hard enough the other direction. The sun itself changes too. Ages ago it burned dimmer, granting Venus a shade more grace. As the star brightened, thresholds moved. The inner edge of comfort crept outward, and one sibling slipped across the line. Earth still sits inside the habitable band, but close enough to the inner rim that humility is wise. The sister shows what happens when that rim is crossed and no slow mechanisms remain to ease things back. Weather under such a sky obeys its own logic. High above the furnace, winds take the cloud tops around the planet in about 4 Earth days super-rotation, a belt of speed that never loosens while the surface turns so slowly the day stretches long beyond our sense. Up there, the air is cool by comparison, though it is laced with acid. You could float at that height and find pressure close to what the body knows at sea level, but the mist would nibble at any unguarded surface. Droplets sometimes begin a downward journey like rain, only to vanish before they touch ground, boiled back to vapor as they fall. It is a planet where the sky tries to cry and can't. Lightning might thread those clouds as well. Some instruments have heard the quick crackle of charged air discharging, a flash hidden inside curtains of sulfur and glare. Others have stayed silent, leaving the question open, like a heartbeat you think you hear in the next room. If those storms do spark, they are another outlet for the great energy stored in that heavy air, a cousin to our own thunder, but raised in a harsher home. The warning written in this atmosphere is plain. Small increases in greenhouse gases can warm a planet you and I find comfortable. Leave the increases to run, and they can make a new world altogether. The balance is not guaranteed. It is earned and kept through many quiet processes working together. Studying Venus is sobering because it shows the end of a road we do not wish to try. Studying Venus is hopeful because it lets us test our understanding of climate, where the dials are set far beyond our own. There's another kind of lesson, the lesson of pressure. Imagine descending with perfect protection, feeling not just heat but weight settle over you, like an ocean made of air. On Earth, We live under a single atmosphere at sea level, roughly 1 kilogram pressing on each square centimeter of your skin. You do not notice because your body answers with equal push. On Venus, that pressure climbs to 90 kilograms per square centimeter. Every postage stamp patch of you would carry a person's weight. Spread that across your frame and the mind balks. The numbers feel like a dream, too heavy to wake from. Divers learn this language in water. Every 10 meters down adds another atmosphere of pressure. To feel what Venus feels like, you would sink to around a kilometer beneath the sea, a place reached only by submersibles in steel. On Venus, that same squeeze belongs to the sky. It makes the air itself a depth, the horizon a kind of seabed that burns. Machines have tried to visit and learned respect in minutes. The Soviet Venera landers went first, armored like small submarines with thick shells and cooling systems. They dropped through yellow haze and knelt on hot rock long enough to whisper back a few pictures and measurements. Then the world claimed them. The longest survived just over 2 hours. Nothing exploded. Nothing dramatic happened. Heat soaked in, pressure pressed on, and the electronics grew quiet, the way any living thing would in an oven at the bottom of an invisible sea. Under such weight, materials behave in strange ways. Melting points shift, chemical reactions change pace, even sound moves differently, muffled and bent by the dense air. If you clapped there, the noise would be swallowed into the thickness. Traveling, yes, but dulled, a soft thud in a room full of quilts. The land would look odd to eyes tuned to blue daylight. The sky is not blue here, but tawny, a dim orange-brown. Distance blurs, as though you were peering through water. The sun shows as a pale coin, robbed of sparkle and sharpened edges, a suggestion more than a source. Engineers who design dreams for Venus often speak of difficulty in gentle voices. Mars is cold and dusty, but you can imagine a suit, a shelter, a day of work. Venus asks for alloys that shrug off acid and heat, pressure hulls that won't bow, cooling systems that can carry the furnace away faster than it flows in all to win a few hours, perhaps a day. Every mission to the surface is like sending a submarine into fire. The air's thickness changes motion too. Even slow winds have muscle when the medium is dense, like a river pushing at your knees. Up high, the hurricane speeds bite around the planet. Near the ground, breezes crawl, yet each movement carries weight. Dust doesn't dance. It drifts and settles with purpose. The whole atmosphere feels present, not as an idea, but as a mass, a body wrapped around the world. What strikes the heart is how contingent it all is. None of it was promised. A touch more distance, a little more water held, a crust that kept trading carbon with the mantle. Any one thread might have softened the story. Earth, only slightly farther out, grew a sky we can breathe and a sea we can love. Venus, born beside it, let a few safeguards slip and became a parallel reality where the sky weighs like an ocean and the heat never sleeps. Think of pressure not just as a number, but as a symbol. The feel of balance lost, of helpful feedbacks turned into gears that grind. The planet is pinned beneath its own air, a gentle truth with sharp edges. And yet even this offers a gift. Venus isn't an enemy. It's a stern, precise teacher. It shows how worlds tip and how hard they are to lift back, how beauty can still be honest in a place that would undo us. Cloud tops like silk, a crescent bright enough to sketch a shadow, a faithful rhythm that still honors the oldest watchers. So the lesson arrives in a hush. By simply being itself, Venus marks how narrow the ledge is between shelter and severity. If you could stand there, spared for a moment from acid and heat, you wouldn't feel open sky. You'd feel an ocean made of air pressing from all sides, the sun reduced to a pale smear. The image is humbling and a little haunted. Two near twins, born from the same dust, one becoming a cradle, the other a chamber where warmth and weight never let go. We grow used to a certain rhythm and begin to trust it. Earth spins from west to east. The sun rises where the day begins and sets where the night gathers. That comfort is so deep, it starts to feel like a rule. Venus declines the rule with quiet stubbornness. It turns backward. The sunrise comes in the west and the sunset in the east, a mirror of our instincts. And it turns so slowly that a full rotation takes about 243 Earth days. Its year, the loop around the sun, is shorter, roughly 225 Earth days. The planet completes a lap before it completes a spin. Time bends in odd ways under such a schedule. Why it spins this way is part history and part guess. The early solar system was a rough neighborhood. Giant impacts were ordinary. A collision could have tilted and slowed the young planet, even flipped its direction. Later, the sun's long patience tidal tug spread across billions of years might have finished the job, easing the spin into its current backward crawl. Or both stories could be true together. A shove at the start, a steady pull afterward, and a final state that feels less like chaos than a different kind of order. Stand on the surface, and the consequences write themselves across the sky. Daylight would not hurry. The sun would creep, taking weeks to lift, more weeks to drift and fade. Twilight would linger like a low ember, caught in thick air that refuses to let edges stay sharp. Night would stretch, too, not cold and star-spattered, but heavy and long, the glow above never quite dark, the heat beneath never quite spent. Because of the way Venus rotates while it orbits, the time from one noon to the next, its solar day, comes out to about 117 Earth days, a curious shortening created by the planet's backward spin slipping against its year. Living beings on Earth breathe to a 24-hour drum. Cells keep time. Leaves wake and sleep. Migrations and meals pay attention to dawn and dusk. On Venus, the drum dissolves into a slow, unfamiliar rhythm. Months of light would bear down without relief. Months of dimness would follow without cool. The biology we know would lose its footing. Only something adapted to a tempo beyond our imaginings could find a way to persist, if anything could, which is doubtful at the surface, where heat cancels every other plan. Above, the atmosphere chooses its own pace. High clouds circle the planet in about 4 Earth days. Super rotation, a rush that ignores the ground's reluctance. Near the surface, wind crawls. Aloft, air sprints, completing lap after lap, while the planet below turns backward and slow. It is as if the sky has decided not to wait for the stone. Even the way Venus steps across our telescopes carries the imprint of strangeness. Those changing phases, crescent to gibbous to nearly full, helped reveal that it orbits the sun and not us, an early clue that the heavens are not built around Earth. Later, as measurements accumulated, the backward spin became clear, and the planet that once seemed so steady in evening skies turned into a quiet riddle about how worlds choose their motions. There's a softness in accepting that not all rhythms match ours. The universe keeps to patterns, but not the ones we would write if given the pen. For every comfortable 24-hour day, there is a long, backward turning somewhere, a year that outruns a spin, a sky that behaves like a different language. None of this is disorder. It's simply another grammar, one that asks us to listen more carefully. Heat on Venus is not a mood, it is the definition of the place. The ground simmers around 460 degrees Celsius, hot enough to melt lead or zinc into quiet pools. There are no cool hours at dawn and none at midnight. No winter to slap the hand of summer away. Mercury, closer to the sun, seems like it should hold the crown for burning, but Mercury lacks an atmosphere. Its days roast, its nights freeze. Venus traps heat the way a thick quilt traps breath. Energy slips in through the cloud tops and struggles to leave. What would be weather here becomes something else there. Not temperature changing, but heat redistributing. Energy marching around and around within a closed room. The greenhouse effect is a friend on Earth. The reason our seas do not seal over with ice from pole to pole. Friends can overstay. On Venus, carbon dioxide rules more than 96% of the air. With that much catcher in the sky, infrared radiation leaving the surface is seized and sent back downward again and again. A long, stubborn relay. The result is a world that hardly knows difference between noon and midnight or equator and pole. Winds high above help blend temperature, carrying heat around in a few days and leaving the thermometer pointing to the same impossible number almost everywhere you might go. Geology listens to temperature, too. Metals that on Earth keep their shape softened there. Some melt. Rock itself glows faintly in infrared, a kind of invisible light that tells you everything is trying to cool and cannot. Imagine a cooker, sealed too well, the dial turned high, the steam unable to find a seam. That is the surface of Venus radiation searching for a path outward, the atmosphere feeding it back in. The balance planets try to keep is simple to say and complicated to achieve. Incoming sunlight versus outgoing heat. Our world receives, warms, and then radiates away, with greenhouse gases gently holding some warmth near the surface. Venus shifts the balance. Carbon dioxide is exquisitely good at absorbing the wavelengths a warm planet tries to shed. Each photon that would depart meets a net. Most are tossed back. Over a long time, the system drifts to a new equilibrium, far hotter than the old, and nothing inside the cycle seems able to nudge it back. There's a memory under that heat, though. Early Venus may have been milder thin clouds, perhaps water pooled in lowlands, but the sun brightened with age, as stars do. Water began to evaporate faster, and water vapor itself is a potent greenhouse gas. More vapor meant more heat held. More heat meant more evaporation. The loop tightened. Oceans, if they existed, boiled away or were broken apart, high in the atmosphere, hydrogen leaking to space, oxygen reacting with rock. Without seas to sink carbon as carbonate minerals, carbon dioxide remained aloft, building the thick air we see now. Once the tipping began, nothing reached back to pull the planet into gentler weather again. The thought that Venus might once have been calmer does not scold, it clarifies. Small changes, a bit more sun, a bit less water held onto, a crust that doesn't trade carbon with its interior the way ours does, can combine into a lasting transformation. On Earth, plate tectonics brings carbon up and takes it down. Weathering locks it away. Biology joins the cycle, and oceans act as a vast buffer. Take away those stabilizers, and heat keeps its gains. Constancy is its own kind of strangeness. We are used to seasons, to the surprise of the first cool morning, to the relief of evening after a hot day. On Venus, heat is the floor and the ceiling. The only rhythm left is circulation, cloud tops racing, energy moving, pressure holding. The ground glows, the air hums with trapped warmth. The numbers barely flinch across long stretches of time. Before the truth sifted down through clouds and instruments, imagination dressed the planet in jungles and swamps, an easy mistake. To look at the brightness and think, lush. The reality turned out starker, and in its way, more dramatic. Basalt plains, mountains with mythic names, rivers, not of water, but of frozen lava, mists not of rain, but of acid. Fiction softened it, nature did not. What draws the eyes from far away is the cloak those clouds make. They give Venus its gem-like shine and hide everything beneath. These are not water clouds the way ours are. They are made of sulfuric acid, a product of high sunlight, volcanic gases, carbon dioxide, and the small thread of water vapor that remains. Sulfur dioxide rises, finds water and ultraviolet light, and is transformed into droplets that gather and float. Layer upon layer builds a bright mirror that scatters sunlight so well the planet can cast faint shadows on a moonless night. The same mirror that turns Venus into a spark in our dusk also denies it a clear horizon. If you could stand there, you would never watch weather clear to blue. You would never see stars. The sky would keep a perpetual glow golden, yellow-orange, because thick carbon dioxide and acid haze filter light differently than the air we know. Shorter blue wavelengths are swallowed. Longer, warmer tones seep through. It becomes a sunset that never resolves into night. Rain forms up high, but the story ends midair. Droplets grow heavy and begin to fall. As they sink into denser, hotter layers, they boil away, returning to vapor long before they can paint dampness on stone. A cycle that never finishes. Sulfur rises, acid forms, rain begins, rain vanishes. The ground stays dry, not because clouds don't weep, but because the heat will not allow their tears to land. Even if a stubborn drop reached rock, the temperature would snap it back into gas in an instant. Light behaves strangely in such an atmosphere. Shadows blur, edges soften. The sun itself is a pale disk behind gauze, not a hard star, but a suggestion of one. The landscape looks close, even when it isn't. Distance pressed flat by the thickness of air. Sound would carry, but the density would muffle it. No bright clap, just a dull pressure wave rolling through heavy gas. All of this, the backward spin, the long day, the uniform heat, the acid clouds, sounds like a story written to emphasize difference. It is also a story about the nearness of outcomes. Shift a few dials at the start, and a world wanders into a new kind of stability. The same ingredients, mixed to a different recipe, can produce a furnace with a sunset that never ends. The same family, different lives. Pressure comes back to mind here, not only as a number, but as a sensation. Imagine a sky that presses like water, a weight that never lifts. The probes we sent were less like spacecraft and more like deep-sea vessels, armored against both heat and gravity. They carried thick shells, precise seals, cooling systems that fought the furnace second by second. For a while, they managed it first minutes. Then, for the luckiest, an hour or two before the quiet reclaimed them. Nothing exploded or failed with drama. It was simply the world closing its hand, returning to stillness under conditions that offer no mercy and no echo. And yet, grace lingers there. From orbit, the clouds shimmer like silk. The crescent shines bright enough to draw a shadow, and the rhythm of its twin rolls, morning star, evening star, never falters. Knowing what breathes beneath that beauty makes Earth's calm feel both fragile and intentional. Oceans that exhale and inhale for us, rocks that lock away what would choke the air, forests that turn sunlight into food. None of it was promised. They are favors of circumstance, the quiet decisions of physics allowed to play out in our favor. When the mind drifts toward Venus, it's best to hold two visions at once: the jewel and the furnace, a sun that rises in the west and sets in the east, taking months to cross a sky the color of smoke and honey, clouds that sparkle from space yet burn in person, rain that begins its fall and never touches ground, heat that behaves not as weather but as law. There's no anger in it, no cruelty, only a kind of cosmic composure. This is how the planet found its balance, strange and unrelenting. The few machines we've dared to send into that balance arrived dressed in armor. Acid mist gnawed at their seams, winds clawed at their frames, and visibility vanished into luminous haze. Lenses clouded, metals blistered, coatings gave way. Still, in their brief descent, they gathered something precious, a few bright notes from a sky that tries to smother every sound. What they found was not chaos, but constancy, chemistry in ceaseless motion, yet a planet holding one unwavering mood. The acid, the heat, the stillness, these are not mistakes, but equilibrium in another language, written in sulfur and endurance. There's a strange tenderness in imagining an entire planet lit forever in amber. Horizons soften, shadows lose their edges, and every surface seems to glow from within. The beauty doesn't forgive the danger, but it does exist alongside it. From far away, that veil turns the whole world into a lantern, a pearl that answers starlight with its own. It's easy to see why eyes have followed it for so long, why stories gathered around it like moths around a light, even as the truth beneath the glow proves harsher than anything first imagined. Set against our skies, the contrast sharpens. Our clouds are the carriers of rivers, stitched through with rain that feeds soil and seed. They part for blue and at night for the studded dark. On Venus, the ceiling never lifts. The clouds do not nourish, they deny. They build not lakes but illusions, phantom showers that rise as vapor before they can finish their fall. What feels familiar, a sky full of bright, shifting forms, turns out to be a different language entirely. The same idea, clouds, can play opposite roles on different worlds. That difference matters beyond our neighborhood. Many of the distant planets we've discovered are wrapped in thick atmospheres, their faces hidden the way Venus hides its own. Some walk the same narrow edge of heat and pressure. Some live past it. Understanding the sulfuric veil here lets us approach those far-off skies with something more than guesswork. Venus, difficult and close, becomes a key that turns and locks many light years away, teaching us how common gentle climates might be and how easily they might be lost. Hold the image clearly. Beneath a jewel-like gleam lies a ceiling that never breaks. Clouds drift forever. Rain begins and unbegins, dissolving before touch. Sunlight filters down in old gold tones, a muted day that never quite becomes night. Nothing in that picture is ours, yet something about the way light behaves still feels nearly right, like a remembered dream that slips just out of reach when you try to name it. The clouds are not decoration. They are the essence, mask, and mirror at once, hiding the surface while telling you exactly what kind of world could grow beneath such a sky. Whole personalities of planets are written as much in air as in stone. For centuries, the surface stayed storyless. Telescopes showed only brightness. No mountain, no plain, no scar could be seen through the curtain. Then radar took the role of sight. Waves of radio slipped through the haze, struck the ground, and returned with the shape of the hidden land cupped in their echoes. In the 1,990 seconds, maps arrived with the quiet confidence of a well-tuned instrument. They revealed a world remade again and again by fire, mountains, and craters, yes, but most of all, volcanoes, and the plains those volcanoes left behind. What the maps whispered most insistently was abundance. Volcanic rocks sprawled over more than 4/5 of the surface. Lava had poured in sheets so wide they blurred the idea of shore and field, flowed for hundreds of kilometers, and cooled into rolling plains that smooth away older marks. Wrinkle ridges pucker those plains like skin that has cooled too quickly. Rising from them are giants, shield volcanoes the size of countries. One of them, Mont Mons, swells over 8 kilometers tall and spreads so far that, if set on Earth, its flanks would blanket whole nations. It isn't alone. Peaks, domes, and complicated calderas dot the map, a forest of stone where each trunk is a story of something molten, having found a path to daylight. Unlike our chains that trace the edges where plates meet and argue, Venus seems to build mountains from fixed hotspots, a stove under a single place on the pan, not a moving burner sliding beneath a crust cut into mobile rafts. Thick, sometimes sticky lava has, in places, pooled and spread into broad, flat mounds called pancake domes, as though a slow batter had been poured and then stilled. Elsewhere, the surface bears rings and ovals known as coronae, vast circles left by pulses of heat rising from the interior, pushing the crust upward, cracking it, and then letting it sag the way a souffle rises and settles. Some coronae run hundreds of kilometers across, their rims and fractures mapping forces you cannot see but can trace with a finger on the page. Craters, which on many worlds accumulate like years on a tree, are oddly sparse here. That scarcity speaks of youth, not youth in any human sense, but geologically young. The suggestion is sobering. At some point in the last few 100 million years, lava may have rolled over much of the planet, burying old landscapes under new, a reset, not total, but wide. The older record now lives mostly in islands of rugged country. The radar maps call tessera tiles tangled regions of ridges and valleys that stand above the plains as if they were survivors of an earlier arrangement. Whether Venus still breathes fire is an open door with a shadow in it. Some radar images hinted at subtle changes, shapes that seemed altered, as if new flows had crept across them. Measurements of the air have found sulfur dioxide shifting in ways that might be explained by eruptions flicking on and off like a pilot light. None of it is courtroom-proof. All of it is suggestive. If the planet still erupts, it does so beneath a pressure and heat that mop up evidence almost as fast as it's made. The thought adds a nerve to our picture, a hidden world not finished with its making. Mountains lend grandeur of another kind. Near the north, a range called Maxwell Montes rises nearly 11 kilometers above the mean surface. higher than Everest measured from sea level, if different in its setting and meaning. Those peaks flash bright in radar, likely because some compounds condense there as the air thins and cools. Not snow, nothing as gentle but metallic frost, perhaps lead sulfide or bismuth compounds glittering in radar eyes beneath a sky that trades blue for sulfurous gold. It sounds like fantasy until you remember the chemistry and pressure. Then it sounds inevitable. The tessera terrains carry their own fascination. Imagine plates of crust crumpled from several directions at once, cracked and shoved until the geometry becomes intricate. These regions are among the oldest places we can still see. Fragments that stood through whatever resurfacing washed over everything else. They confuse and attract geologists in equal measure, telling of forces that act like tectonics without behaving as our plates do, buckling, shortening, stretching, but within a crust that refuses to break into the mobile mosaics we take for granted on Earth. Everything on the surface bears the mark of a planet shaped more by inner heat than by water or wind. On Earth, rivers carve, glaciers plane, and air sands corners down. On Venus, there is no flowing water to speak of, and the dense air near the ground moves too slowly to be a sculptor. Features remain stubbornly clear until buried or deformed from below. Time there feels paused between eruptions, like a stage set waiting for the next act of fire, rather than a river slowly revising its lines. This is geology, stripped to a simpler argument. Heat trying to leave, rock trying to answer. With no plate tectonics to shuttle crust down and new crust up, the planet vents by swelling and cracking and pouring. Plains spread outward, mountains lift, where plumes push, coronae bloom and collapse, a patchwork sewn by pressure rather than stitched by continental drift. The result is a map that carries both youth and age, fresh surfaces plate-wide and older, knotted islands standing through it. When the radar veil pulled back further, something even more familiar yet strange came into view. Vast highlands standing above the volcanic plains, continents in the loosest, most careful use of the word. Ishtar Terra near the north, wide as Australia, holds the planet's tallest range and a rugged maze of faults and folds. Aphrodite Terra sprawls across the equator for more than 10,000 kilometers, a continent-sized expanse as large as Africa, riven and uplifted, a tapestry of stress patterns without an obvious source in the drifting, colliding plates that write our own continent's sagas. On Earth, continents float because they are made of lighter rock and because plates move. They raft over the mantle, meet and buckle into mountains, pull apart to open seas, and dive beneath one another to be reborn. Water greases the system. Heat powers it. Time organizes it into cycles. Venus seems to have chosen another path. Its crust is a single shell, thick, reluctant, and largely locked. No worldwide grid of moving pieces, no long parade of collisions and separations. Then how do highlands rise? One answer is Plume's columns of hot rock that rise from deep within, flexing the surface upward like a thumb pressing on the underside of a drumhead. On Earth, a plume can build a chain of islands as a plate moves across it. If the surface is fixed, the same upwelling could swell a whole region into a plateau. Another answer is cumulative stress. A crust unable to break into plates still has to respond to forces from below. It wrinkles locally, crumples into ridges and valleys, and holds those shapes because nothing is moving them along. The truth may be a mixture, with different processes sharing the work across long spans. Water's absence is a clue. On our planet, water helps rock flow, lowers melting points, and lubricates faults. It makes plate tectonics easier, perhaps even necessary. Without oceans, Venus may never have had the conditions for plates to decouple and travel. Its lithosphere thickened and stayed put, forcing heat to vent close to where it formed. In that context, Ishtar and Aphrodite become less like continents carried somewhere and more like places lifted where the planet had no other choice. The highlands cradle much of the tessera terrain, the tough, tangled patches that could predate the great resurfacing. Studying them is like peering into a window that the lava couldn't reach in time, a glimpse of older patterns caught in a net of younger stone. From a human point of view, continents that never wander feel both restful and uncanny. We are used to our maps changing over eons, land masses drifting, colliding, and tearing apart, climate tilting as ocean passages open and close. Here the stage is bolted down. The drama comes from below. And yet names help. Ishtar and Aphrodite, goddesses stitched into the history of the planet's light in our skies, now attached to whole regions of rock. Geography becomes graspable when it has a language we recognize, even if the processes underneath insist on their difference. The lesson travels far. For a long time, we imagined plate tectonics might be an inevitable outcome on any rocky planet of a certain size. Venus sits nearly our twin in mass and diameter and says simply, not necessarily. The details, the presence of water, the thickness of the lithosphere, the way heat is born and bled, decide as much as the broad strokes do. That nuance matters when we look outward. Finding a world the size of Earth in a comfortable orbit says something important, but not everything. It might carry oceans and rain and moving continents. It might wear clouds of acid and hold a crust that acts like a single piece. Similar beginnings can diverge into foreign lives. Family resemblance does not guarantee familiar rooms. Above the continents and plains, an invisible race keeps time. High in the atmosphere, where the air thins to a bright haze, winds circle the planet in about 4 Earth days. Super rotation, we call it, as if adding a hyphen could make the strangeness sit still. The ground below takes 243 days to turn once, lazily and backward. The sky ignores that tempo and sprints eastward, dragging cloud tops into long, elegant streaks. At those heights, speeds can rival or exceed our fiercest storms hundreds of kilometers an hour, not as an event, but as the average state of things. Why should the air refuse the ground's pace? The reasons are layered. The sun warms the planet unevenly. The atmosphere, thick with carbon dioxide and stacked with reflective clouds, stores that warmth and moves it with extraordinary efficiency. The slow spin means Coriolis forces the twisting effects that sculpt weather on Earth behave differently, allowing vast patterns to organize without being broken into smaller swirls. Friction at the surface is strong because the air is dense, but up high, where it is thinner and cooler, winds find less to resist. Waves of momentum born lower down can propagate upward, adding push. Once such a flow is established, it feeds itself like a great engine, redistributing heat and keeping the whole system in motion. If you stood on the ground, the winds would hardly register at first touch. The air near the surface is so heavy that even when it moves, it feels like a slow current pressing rather than a breeze tugging. Dust and grains do not dance. They settle and lift with deliberation. But above your head, the sky runs laps on its own schedule. From orbit, we've watched the clouds stream, pour and rebuild, a continuous river whose banks are the planet's horizon. That engine pairs with the greenhouse heat to erase the familiar contrast between noon and midnight, equator and pole. Energy pumped into the system near the dayside is dragged quickly around the world, ironed into uniformity. Twilight takes weeks because light has to bleed through so much haze. Dawn and dusk smear across days because the sun's motion is slow and the atmosphere refuses sharp lines. Time there will not be rushed or divided into the tidy segments that govern our lives. Even in the face of corrosion and speed, our probes manage to measure, to taste, to listen. Coatings dissolved, spectrometers clouded, but for minutes, then hours, data flowed. Compositions etched into numbers, pressures tallied, temperatures confirmed, winds heard as changes in frequency against the heartbeat of a signal. Each machine became a small, brave sense organ dipped briefly into an alien body. Together, their short lives made a coherent picture, a world whose air is harsh, whose ground is young, whose sky is fast and bright and poisonous. The story that picture tells is not tidy, and that's a gift. Venus shows that a planet can be chemically busy and climatically steady, geologically violent and eroded hardly at all, visually dazzling and physically unforgiving. It shows that continents can rise without drifting, that mountains can wear frost that is metal, that rain can be real in the cloud and impossible on the ground. It shows that an atmosphere can choose a speed of its own and keep it. It shows, above all, that kinship does not require sameness. Think again of the lantern in our night. Behind that calm lies a sky that never parts, a ground that remembers fire, winds that outrun the planet they belong to, and clouds that both reveal and conceal. The more we learn, the more the brightness in our evening feels earned, not because the world is kind, but because it is complete in its strangeness. Knowledge doesn't steal wonder, it deepens it. You can stand under Earth's open blue, watch ordinary clouds break apart and gather again, and still feel the amber hush of Venus somewhere in your chest, a reminder that skies come in many languages. Where rock meets air on Venus, the meeting is blunt and elemental. No river leaves its signature, no storm carves a path. Heat rules, pressure enforces, and lava has done most of the shaping. The rest belongs to the slow breathing of the crust, rising and settling where it cannot drift on plates, speaking directly to the mantle beneath. The landscape reads like the record of those breaths. An inhale, and the ground swells. An exhale, and it sags. Then, a long molten sigh, frozen into plains of basalt. Then stillness again. Imagine yourself there safe, untouched, standing on one of those highlands. The sky glows the color of tarnished metal. The sun, dim and distant, hangs like a coin seen through gauze. The ground beneath your boots is hard and scarred, crusted where lava once cooled, crossed with ridges that fade into the haze. In the distance, another plateau rises. Between you lies a plain like a petrified sea, its surface folded into quiet wrinkles. You listen. Sound doesn't so much reach you as press against you. You lift your hand and feel the air itself thick, heavy, almost liquid pressing back. The planet keeps no rhythm but its own. There is no wind to rush, no rain to soothe, no wave to mark time. Only endurance, pure and absolute. From such a still world, Earth feels almost miraculous. Our shifting continents, our seas that breathe, our gentle exchange of seasons, all of it depends on small, particular mercies, a touch more distance from the sun, a crust that learned to move, oceans that lingered, life that wove itself into the chemistry of stone and air. Venus chose another path, or was chosen by chance, and became something both beautiful and forbidding. It remains as it has always been, a bright lantern at evening and dawn, a teacher of thresholds, a proof that there is more than one way for a planet to be alive. Far above that dim, brooding surface, the air loosens its grip and turns to gold. There, in the upper haze, the winds keep a single vow. They move in one direction, at one steady pace, as if the entire sky were a single, seamless river. On Earth, our weather is restless, storms bloom and break, jet streams wander, air currents braid and clash. Venus prefers constancy. Its clouds race around the globe in just 4 Earth days, a high, swift current flowing endlessly east to west, while the planet below drifts backward in slow motion. The atmosphere laps its world again and again, dragging its veil in circles, unmoved by the stone that turns beneath. From the ground, if you could bear to stand there, you would feel the paradox in your bones. The near air is heavy and reluctant. Breezes creep like slow currents. You look up into the haze and see only a pale disk where the sun should be, its edges softened by depth upon depth of cloud. And yet above, beyond sight, winds faster than a jetliner are running a marathon without a finish line. Stillness at your feet, speed overhead. It's a quiet dissonance, the kind that makes you aware you're in a place that obeys rules it wrote for itself. Those winds are not a quirk. They are the planet's grand equalizer. They take heat from wherever sunlight can press it into the air and move it across the world in days. Day and night, pole and equator, mountain and plain differences that dominate our weather are sanded down into near uniformity on Venus. The result is a furnace without corners. The thermometer points to the same cruel number, whether you wander toward the poles or wait through the long, drawn-out noon. Energy is captured by carbon dioxide and sulfuric haze, then carried aloft and around until nothing stands out enough to change the feel of the ground. Chemistry rides those winds as well. Sulfur dioxide climbs from below, born of volcanic breath, and deep heat meets sunlight and the whisper of water, and becomes droplets of sulfuric acid that thicken the clouds. The atmosphere is a global mixer, folding its ingredients back into themselves. A sample from anywhere is never only local. It carries hints of distant places stirred into the same golden soup. To read that air is to read movement, not merely composition. Why the sky sprints while the planet barely turns has become a long, patient puzzle. One answer speaks in waves. Sunlight heats the day side more than the night, and that unevenness gives birth to atmospheric waves that march upward, carrying angular momentum with them. As the waves break or dissipate, they hand that push to the high winds, and the winds keep it. Another answer follows planetary scale patterns, the kind of broad, gentle undulations that only a slow spinner permits, reinforcing the flow instead of tearing it apart. Friction near the surface steals energy, but up high there's room to run. None of these explanations stands alone as final truth. Together, they sketch a system that teaches itself to move and then refuses to stop. There's poetry in the mismatch. The sky circles the planet in days. The planet takes months to turn once, and does so backward, fast above, languid below, restlessness in air, defiance in stone. When you picture Venus as a character, the atmosphere is the wanderer that never sleeps, and the globe is the unhurried companion whose steps point the other way. That duality gives the world its texture, an interplay of constancy and motion that is easy to feel and hard to forget. Seen from here, as a jewel in deepening blue, we aren't just catching reflected sunlight. We're seeing the signature of an engine, clouds hauled round and round, edges of streaks lengthened into graceful arcs. Beneath that pale lantern's shine, a surface swelters and barely budges. Above it, air is a traveler that refuses to sit. The sky outpaces the ground. The planet lingers. Both keep time, each in a different meter. Electricity may find its way into that meter too. Lightning has always carried drama for us. A quick blade of white across a dark field. A clap that makes the chest vibrate. Venus hides its sky, so the question becomes more delicate. Does lightning bloom inside that perpetual haze? From the first brave descents, the hints arrived, as radio whispers bursts of electromagnetic noise recorded by descending probes, signatures that looked like storm-born disturbances. Later, orbiters heard low-frequency tones known as whistlers, the kind our own planet's lightning hums along magnetic field lines. The clues are indirect, the way footsteps under a door are indirect, yet they come again and again. Skepticism has its place. A thick atmosphere meeting the solar wind can produce its own radio murmurs. Turbulence can masquerade as discharges. No eye has watched a clear bolt fork across a Venusian sky. The clouds themselves are different from ours, more laboratory than cloud-bank sulfuric acid droplets riding carbon dioxide. Almost no water to do the familiar work of ice and rain. On Earth, lightning is born from collision between ice crystals and liquid droplets inside, towering anvils. Charges separate, a threshold is crossed, and a sudden equalization tears the air into light and sound. On Venus, any discharge must grow from other collisions, acid droplets brushing, ash and mineral dust from eruptions, offering surfaces for charge to gather, layers of clouds sliding past one another as the winds race. If lightning lives there, it likely behaves in a tone of its own. The dense air would slow the strokes, stretching them into longer glows, a fraction of a second that lingers, a sheet of illumination diffused through yellow haze rather than a sharp, branching lance. A watcher on the ground, if the ground could be watched, would see the sky blush and fade, brightness without edges. Thunder, in that weight of air, would change its voice as well, less a crack, more a low-pressure wave, rolling like a far-off drum, felt in the ribs as much as heard by the ear. Storms here would not gather, as our ocean-fed towers do. They would be born of chemistry and heat inside layers that never open to blue. Their power would work inside curtains that never lift. The image is quietly astonishing. A world without weather as we know it, still making room for electricity to write quick lines across its own script. Each flash, if it happens, would become part of the atmosphere's hidden bookkeeping, nudging sulfur and carbon into new combinations, sketching and erasing reactive species that settle back toward balance. Even lightning, then, would be an accountant, an agent in a cycle rather than a spectacle alone. The certainty we'd like still waits, but the weight of clues has tilted many careful minds toward yes. New instruments are being designed to catch the light itself, not only its echoes on radio waves to watch for the slow, diffuse flare of a Venusian strike within the acid veil. If those glows are caught, another layer will settle onto our understanding. A planet that is not only hot, not only heavy and cloud-bound, but also alive with charges that occasionally find a path through their crowded sky. It's fitting, in a way, that the world named for love in so many old tongues might keep a second nature serene from afar, fierce from within. The jewel holds storms. The goddess carries a blade. Beauty does not excuse power, it accompanies it. Each hidden flash would remind us that beneath any polished surface lives a working set of forces, and that nature writes in more than one font. When the first careful attempts to touch Venus were made, the odds of success were humbling. The Soviet Union pointed a long chain of metal hope at a destination known only as brightness. The Venera mission's dozens if you count every attempt, a steady march from the early 1,960 seconds into the 1,980 seconds, learned the world the hard way. Early flights missed, failed, or were swallowed before they could speak. Even those that bit into the atmosphere were surprised. Expectations of a mild, cloud-wrapped twin softened into facts about a crushing, carbon-rich furnace. Venera 4, in 1967, dipped into the air and sent back the first direct numbers from another planet's sky. It didn't reach the ground, but it did something more fundamental. It ended the dream of jungles hidden under a white canopy. The readings were heavy and hot, beyond the guesses. The atmosphere was almost entirely carbon dioxide. Temperatures rose and rose. Pressure climbed toward figures no one wanted to believe. Venus had been patient with our stories. It now asked for new ones. Engineers answered with deliberate stubbornness. Landers grew into pressure vessels, small, squat bathyspheres for a sea of air with thick walls, hardier seals, and cooling systems, squeezed into bodies no bigger than a chair. Venera 7, in 1970, managed a true landing and a faint, fragile transmission for about 23 minutes, history's first whisper from another planet's surface. Parachutes had to be adjusted for air so thick that descent itself was an engineering riddle. The signal was weak, the data sparse, but the feat was real. A machine touched that ground and spoke. Then came pictures. Venera 9 and 10, in 1975, sent the first black and white panoramas from the surface of another world. Slabs of rock under a low horizon, the view bent by the refraction of dense air. The images look ghostly now, grainy, curved, but in them lives the shock of first sight. Not a swamp, not a sea, a stony plain lit by muted daylight, the sky pressing like a lid. Later, in 1982, Venera 13 lasted for more than 2 hours and returned color the ground, orange-brown, the sky jaundiced yellow, the rocks flat and layered as if set by a careful hand. It sampled soil and taste-tested minerals before the heat finished the work that pressure had begun. The lifetimes of those landers were brief, 40 minutes to 2 hours, yet stuffed with fundamental answers. Temperature here, pressure there, chemistry of air and ground, even the sound of wind as a low, steady push. The achievements feel larger when you remember the tools: electronics less capable than a modern wristwatch's brain, film transfer tricks for images, materials engineered to shrug off acid for just long enough. Nothing in those missions pretended permanence. They were made for the sprint, and in sprinting, they opened a window that had stayed closed for all of human memory. The pictures and measurements didn't tame Venus. They reframed it. The planet stopped being a canvas for guesses and became itself a basaltic world, ripped and rolled by volcanism, air thick with sulfuric mists, temperatures so even they made a mockery of day and night. The romance changed without fading. To love a place, you do not need to soften it. You only need to see it clearly. Sight gained new power with radar. Visible light cannot reach the ground. Radio can. In 1989, a modest spacecraft, built largely from spare parts and clear intent, Magellan left for Venus, arriving the next year and beginning a careful peel of the planet's skin. Synthetic aperture radar let it draw from orbit with astonishing finesse, stitching echoes into images and elevations. In the 1,990 seconds, those maps poured in. Volcanoes sprawling wider than countries, broad plains ridged and puckered, coronae ringed like giant fingerprints pressed into warm dough, mountain ranges bright and hard in the radar's eye. The veil lifted in a new sense. We still could not see the surface with our eyes, but we knew its shape and texture in better detail than we had known whole regions of Earth's seafloor at the time. That mapping did more than satisfy curiosity. It told a story about geologic youth, few craters, many flows, and hinted at possibility, changes that might have occurred between passes, gas in the air that rose and fell as if responding to invisible fires. It balanced the Venera ground truth with a planetary view, letting scientists trace relationships between mountains and plains, between domes and rifts, between highlands and the flows that lap at their edges. From those patterns came hypotheses about plumes and sagging crust, about how a planet without plates manages its heat, about how continents might rise without ever wandering. The threads of atmosphere and surface tie back into superrotation. A sky that moves heat with such speed helps erase local signatures at the ground. A surface that renews itself in floods of lava blurs the clock we would like to read in craters. Venus refuses to give away its age in a simple line. It offers pieces, old fragments held high as tessera, broad, younger plains spread like blankets, fresh-looking features that might be truly young or simply protected under conditions that do not weather the way ours do. The result is a world that looks both recently made and deeply worn, depending on where you let your eyes rest. Every time we return to this world in thought, the same gentle astonishment arrives. The planet is consistent without being simple. Its atmosphere makes its own rules and keeps them. Its surface tells a story in lava rather than in rivers. Its clouds shine like silk and bite like acid. Lightning may glow invisibly within curtains that never part. Mountains glint with metallic frost. Continents exist without drift. Winds outrun the planet they belong to, circling endlessly while the ground lingers behind. And still there is calm in the knowing, the uniform wind at the top of the world, the measured chemistry, the reliable orbit, the faithful appearances at dawn and dusk. These are steady things. They do not soothe by promising safety. They soothe by being true. When you look up in the quiet evening and see that bright point above the darkening rooflines, you are catching the blended work of many facts, the reflective power of acid clouds, the relentless circulation, the balance of a greenhouse carried to its conclusion, the discipline of a sky that refuses to fracture into weather as we know it. The brilliance you admire is the calm face of a stormless storm. For 4 patient years, a small craft circled the shrouded planet, tracing path after path until the hidden face began to take shape. Nearly 5,000 loops later, a global portrait emerged, about 98% of the surface rendered with a clarity no eye had ever managed through the clouds. What came back was not a flat world or a blank swath of stone, but a place busy with forms, mountains rising under a heavy sky, valleys stitched with fractures, vast plains frozen from flood after flood of lava. Radar doesn't paint in color. It returns textures and brightness, a language of echoes. Yet, the results felt like art. Patterns leapt from the darkness, swept lines, bright rims, dark basins, each a sentence in a story written by heat. One discovery repeated itself so often, it became the theme: volcanism everywhere. More than 160 large volcanoes stood out, with countless smaller vents scattered around them like sparks. Some were broad shield volcanoes, rising gently over enormous distances. Others were steeper, more complex, built by thicker lavas that refused to run far before cooling. Mixed among these were shapes with their own quiet strangeness: pancake domes, wide, flat mounds formed when sticky lava oozed outward in slow, layered sheets. They looked like someone had ladled batter onto a griddle the size of a province and let it set under a dim, persistent heat. Equally haunting were the circular structures called coronae, immense rings, hundreds of kilometers wide, edged with ridges and broken by fractures, sometimes sagging in their centers, like a souffle that had risen and settled. They read like fingerprints of the interior, places where heat rose, pushed the crust upward, cracked it, and then let it sink back, leaving a scar wide enough to be seen from orbit. On a planet without moving plates, this is how the deep announces itself, by bulging and relaxing the surface rather than shoving continents together. The maps also showed sweeping volcanic plains, smooth expanses where lava once poured for hundreds of kilometers, erasing what lay beneath. The surface lacked the dense population of impact craters you'd expect on an older face. The few that remain suggest a reset sometime in the last billion years. Whether the rewriting happened in long pulses or in an overwhelming surge remains open, but the message is steady. This is not a fossil world. It has been active, and not gently. Fractures run through many regions like careful engravings. Some areas stretch into long rifts, valleys where the crust pulled apart. Others knot into tessera terrain, dense networks of intersecting ridges and grooves, brighter to radar than surrounding plains. Those tessera patches feel ancient, fragments that stood high enough or strong enough to avoid being buried when lava smoothed the world. They are like islands of memory in a sea of newer rock. From beneath the clouds, mountains rise with a starkness that belies the softness of the light. A range near the North Peaks, nearly 11 kilometers above the average surface, flashes bright in radar, likely because exotic compounds condense on cold heights and create a metallic frost. Snow is a dream word here. Think, instead of lead sulfide or similar minerals settling thin and bright, reflecting radio waves like polished stone. How the mountains grew is its own quiet debate. Perhaps slow lift over hot upwellings, perhaps long deformation of a thick, stiff lithosphere. Whatever the mechanism, elevation exists in a world without our familiar recipe of colliding plates, and the summits gleam in echoes as if dusted with a strange winter. Even without true photographs, the images hold an austere beauty. Plains look like oceans mid-swell, their waves stopped in stone. Coronae resemble flowers or mandalas etched by a patient hand. Faults read as scars that healed without vanishing. For geologists, each frame is a cabinet full of clues. For everyone else, they are a reminder that the planet behind the bright evening star is as dramatic as any world we know, only dressed in different rules. The technique that made this view possible feels almost like listening. Where light cannot travel, radio can. The radar sent out a pulse, waited for the echo, and used the timing and strength to infer slope and texture. In doing so, it turned an opaque atmosphere into a window. This way of seeing opened more than Venus. It set a path for exploring clouded worlds and icy moons whose surfaces would otherwise remain secrets. Patience and repetition did the rest, orbit by orbit, until the map felt less like a sketch and more like a memory. By the end, the change was deeper than a catalog. The vision of Venus shifted from a smooth, unknowable globe to a volcanic world, with its own suite of processes resurfacing without rain, mountains without drifting continents, pulses of heat without plate boundaries. The old dream of hidden oceans and jungles faded. The new reality, harsh, specific, compelling, took its place. When the spacecraft finally slipped into the atmosphere and burned, the work did not vanish. The map stayed, and decades later, they remain the baseline for nearly everything we ask about the planet's geology. When you catch Venus bright in the sky, that brilliance hides a ground we now know in extraordinary detail, because a small craft, built with practicality and persistence, learned to see through clouds. Mystery became structure, guesswork became evidence. The radar echoes told a story of scars and plains and peaks, each an act in a long play of fire and change. Thoughts of the future often turn red domes on Mars, dust devils skirting habitat walls, yet a different dream floats in gold. High above the searing floor of Venus, there is a band in the air where pressure and temperature soften into something almost familiar. Around 50 to 60 kilometers up, the atmosphere thins to roughly one Earth atmosphere, and temperatures drift into the range we call comfortable. The mist is still acid, the light still muted, but the numbers, pressure, and warmth cross from punishing to possible. Here begins a different kind of settlement story, not foundations sunk into ground, but buoyancy. In a sky made mostly of carbon dioxide, even the air we breathe, nitrogen and oxygen, acts as a lifting gas. Fill a large envelope with breathable air, and it floats as helium would float on Earth. String envelopes together into an airship or a cluster of balloons. Add platforms and shells, and you can imagine habitats that ride the winds in the safe band above the furnace. Designs sketched for such missions look like families of graceful leviathans, long, pale shapes buoyed by their own air, carrying modules and labs festooned with solar arrays that sip the filtered sun. Concepts have been drawn that send crews to live for weeks in this gentler layer, studying chemistry and weather from within, peering at the surface with radar, while sampling cloud droplets directly. The surface is deadly. The sky is workable. It is a shift in strategy that feels both bold and sensible. Rise above the worst to reach what can be learned. Science fiction has already set cities among those clouds, towers tethered to helium hulls, walkways suspended in amber, airships drifting like patient whales. The romance of ballooning meets the frontier of planetary exploration. The practicalities are fierce, of course. Acid eats. Materials must shrug off corrosion day after day. Power must be harvested from a dim sun and stored with care. Mobility would be relentless and mostly beyond control. Winds at that height circle the planet in about 4 Earth days, so any habitat would be a traveler, whether it chose to be or not. Steering might nudge a course, but the world's great conveyor would win. Residents would learn to live in motion, watching dawn and dusk return many times as they orbited in step with the sky. Some difficulties come with gifts. Radiation so worrisome on bare, dry Mars is softened by the kilometers of atmosphere above. The thick air becomes a shield against high-energy particles. The proximity of Venus to Earth shortens travel times and offers frequent windows to make the trip. Instruments riding in the clouds could measure lightning if it exists, taste trace gases for signs of fresh volcanism, map the ground anew with sharper radar, and gather droplets to learn how sulfuric acid shapes and sustains the haze. If there is any niche in that temperate band where hardy microbes could cling to droplets and make use of chemical energy, a drifting lab would be the right tool to seek them. Children raised in such a place would learn horizons differently. No blue clearing to stars, only a layered glow. No soil underfoot, only floors that hum softly with moving air. No fixed address, only paths that circle the world again and again. Home defined by companions and hulls rather than coordinates. It is not a plan poised for next year. It is a sketch of what imagination might make room for as materials, budgets, and patience find each other. The point is not certainty. The point is that a planet we once wrote off as impossible holds a stripe of possibility if we choose to float rather than dig. The strange grace of this approach lies in the attitude it implies. The goal isn't to conquer the furnace, but to accept the layers and live in the one that gives. To look at the hardest facts, heat, pressure, acid, and then step sideways into a band of air where numbers soften. It's a quiet form of cooperation, letting the planet be itself while we find a way to be ourselves within it. Long before any of this, the bright star at evening was already a companion in story. The light is so insistent that even a hurried passerby can't help noticing. In many languages and lineages, it became a goddess or a herald, a marker for prayer, planting, battle, or voyage. Names were given with affection and caution. The same point of light served as love and war, fertility and power, devotion and omen. It rose in the morning to announce beginnings, and it hovered at dusk to bless endings. To the Romans, it was Venus. To the Greeks, Aphrodite, a beauty linked to the sea and to desire. In Mesopotamia, it carried the weight of Inanna and Ishtar figures, who held tenderness in one hand and ferocity in the other, as fitting for a star that keeps two roles, one at each edge of day. Across oceans, Maya astronomers tracked its rhythm with a precision that still stuns, recording cycles and weaving them into calendars that touched ritual and rule. In the Pacific, navigators folded the morning star into their memory of routes, a steadfast pointer across immense water. In the East, it became the Great White Star and part of a balanced system of elements, an index of order mirrored between heaven and earth. The universality is moving. Wherever people looked up, this light stood out enough to be named and counted on, reliable enough to chart by, mysterious enough to adorn with meaning. When spacecraft finally described the reality beneath the glow, the transformation was stark, but not cruel. The goddess's veil lifted, and we found a place of lava, acid, and pressure. The symbol of love revealed a heart of fire. The irony deepened interest rather than erasing it. Beauty and danger, it turns out, are neighbors often enough that the pairing feels honest. A planet that shines so serenely could have been dull. Instead, it is intense, consistent, and different in a way that teaches. Art kept pace with the facts. Composers gave the planet themes that breathe and reflect. Writers and painters kept borrowing the light for longing and return. making room for the truth that the object of all this beauty is also unwelcoming. The light did not need to be gentle to be a muse. The stories did not have to match the geology to matter. Both can exist. The myth we made together in the long watching, and the reality we uncovered with machines and waves. Next time the evening clears and that bright point leans above the rooftops, hold two images at once. In one, the jewel shines as it always has, carrying centuries of names and prayers. In the other, a landscape of frozen lava, metallic frost, coronae-like rings pressed into stone, rifts cut by stress, and plains so wide their curves only make sense from orbit. Between them runs the work of patient craft, radar echoes gathered over years, maps drawn from spare parts and stubbornness, a quiet transformation of clouds into clarity. Somewhere in the golden layers above that surface, numbers soften into comfort. Somewhere in the high winds, a balloon could float, carrying breath, shielding bodies, and listening to a sky that races while the ground dawdles. The dream is not a promise. It is an invitation to imagine solutions that rise rather than push, to see a harsh world as a teacher, and to let wonder coexist with understanding. Love and fire are not strangers here. They are a pair we've learned to recognize, a bright goddess in our stories, an unyielding planet in our instruments, and a thread between them that keeps us looking up. The greenhouse effect on our world is a gentle accomplice, a quiet warmth that keeps oceans liquid and forests breathing. A thin blend of gases, carbon dioxide, methane, water vapor, holds a fraction of the sun's energy near the ground, just enough to soften nights and steady seasons. Without that thin blanket, Earth would harden into a frozen shell, blue ice in place of seas, wind moving across continents that never thaw. The comfort feels ordinary because we grow up inside it, but it is balance, not default. Shift the scene to Venus, and the same principle becomes a tyrant. The air there is not laced with carbon dioxide. It is made of it. More than 96% of the sky is CO2, stacked deep and heavy until the pressure at the ground feels like standing a full kilometer under an earthly ocean. Add the planet's closeness to the sun, the reflective veil of acid clouds that let light in and trap heat beneath, and the quiet friend turns absolute. Warmth that would be welcome on a spring afternoon becomes a sentence, a greenhouse that never loosens its hold. The difference is scale and bookkeeping, how much heat arrives, how much leaves, and what systems exist to store or spend it. On Earth, carbon dioxide is a trace, measured in parts per million. That trace matters, but it lives in conversation with waters and stones. Oceans drink it, weathering locks it into carbonate rock. Volcanoes return a portion to the air, and life continually borrows and returns carbon with a leaf's ease. The ledger runs long and slow through plate tectonics, crust dives and rises, subducts and erupts, and through the soft commerce of forests and plankton. The sun brightens a little over geologic time, yet the network holds. On Venus, the ledger broke. Oceans, if they ever stood, long vanished, with no water to dissolve carbon dioxide, with no cycling crust to tuck it away, and no biology to nibble at it. The gas stayed aloft and piled higher. Warming pulled more water vapor into the air, and water vapor itself is a powerful greenhouse blanket. More heat freed more vapor. More vapor held more heat. A loop tightened. The balance tipped from steady climate to runaway. The oven door closed and never opened again. To understand what makes the contrast so vivid is to follow the roles on Earth keep drift in check. Water is a mediator. It evens temperature, absorbs CO2, and moves energy around the globe via evaporation and rain. Rock is a long memory. It takes carbon from the atmosphere and holds it as limestone and dolomite until tectonics and time return it. Life is a choir of small voices that matter in the aggregate. Plants and microbes draw carbon from air and sea, exhale oxygen, build shells and soils, and in doing so, participate in the planet's thermostat. It is not that Earth cannot change, it is that changes meet mechanisms that answer back. Venus shows us what happens when those mechanisms are missing or overwhelmed. No plate tectonics to subduct carbon and recycle crust, no ocean to sip and store, no biosphere to weave feedbacks that soften swings. The atmosphere becomes the only stage, and the play that unfolds is monotone. Heat held everywhere, day and night alike, pole and equator nearly the same. The effect is not a mood that comes and goes with season. It is identity. To climate scientists, Venus is not merely a curiosity. It is an experiment running at the far end of the dial. Physics does not swap its rules from world to world. Carbon dioxide absorbs infrared light in the same bands whether it floats above Paris or glows above Mont Mons. The ways circulation spreads heat, the ways clouds reflect and insulate these obey the same equations. Studying a sky so thick and a greenhouse so thorough refines the models we use for Earth. It tests how feedbacks behave when pushed, how temperature profiles settle when convection and radiation wrestle inside a deep column of air, how small changes in composition cascade into large changes in outcome. The warnings written in Venus's story are plain without being melodramatic. Earth is not sliding toward a second Venus. The scales are different, the boundary conditions not the same. But the lesson that balance depends on feedbacks, and that feedbacks can run away when nudged past thresholds, is close to home. Small increases in greenhouse gases on Earth are already reorganizing storm tracks, melting ice, lifting seas, and reshaping habitats. The extreme case next door says, softly and firmly, that tipping points exist. Once crossed, some are not easily recrossed. The idea that Venus might once have worn a gentler face sharpens the point. Early in the solar system, the sun was dimmer. If both siblings were born with water delivered by icy messengers and bound in minerals, then both had the raw materials for seas. Run the climate of a young Venus on a computer, give it shallow oceans and a weaker sun, and the models often settle into temperate states, cloud belts in the tropics, reflecting sunlight, rains falling and returning water to basins, a slow dance that could have lasted hundreds of millions of years, perhaps longer. Long enough, at least, that life might have taken the first steps if the chemistry invited it. But stars age into brightness. As the sun's output climbed, heat began to win over water's cool patience. Evaporation outpaced rain. The sky took on more vapor, holding more heat, and the loop tightened. Ultraviolet light broke water apart in upper layers. Hydrogen, light and quick, escaped to space. Oxygen reacted with rock or drifted downward into the lower air to join other chemical stories. The seas thinned and finally vanished. Without oceans, carbon dioxide had nowhere to go but up into the permanent air. The planet passed a threshold, not all at once like a switch, but firmly enough that return became fantastically unlikely. A dry, hot world took the stage and has not stepped aside since. There is a chemical scar left by this history, a small but telling ratio carved into the air. Deuterium, heavy hydrogen, compared to ordinary hydrogen, is enriched on Venus. The lighter form flees more easily to space. The heavier lingers. Over time, losing water preferentially sheds ordinary hydrogen and leaves deuterium behind. The skew we measure now is a fingerprint, not proof of oceans you could sail, but a strong hint that water once had a larger presence than today's tracers suggest. The implication reaches outward. Many of the planets we glimpse around other stars are close to their suns, wrapped in thick atmospheres, sometimes labeled Super Venus, because size and orbit suggest a fate akin to our neighbors. To separate the possible havens from the certain furnaces, we need practice distinguishing a sky that breathes from one that traps, a climate that cycles from one that locks. Venus becomes a Rosetta Stone for exoplanets, its spectrum a template, its circulation a test case, its clouds a warning about how bright and beautiful can coexist with intense and hostile. The moral content of the comparison is ours to bring. The physics does not scold, but standing under a sky that feels designed for us, it is useful to remember that it is contingent. Earth's balance is the product of many hands, ocean and rock, lightning and life, volcano and ice, sunlight and shadow. The difference between just enough and too much is not wide. Venus tells that truth without raising its voice. Imagine now the present tense of that world pressed into your ears. Sound travels through air by pushing molecules against one another. The denser the air, the faster the push can pass. On Venus, sound would move roughly twice as quickly as it does here. Yet the character of what you hear would change. The weight of carbon dioxide filters high pitches, favors low ones, and smears sharp edges. A voice would drop in timbre, words would thicken and slow as if spoken under a heavy blanket. A clap would not crack. It would present itself as a dull thump, broad and soft. The atmosphere acts like a giant equalizer turned toward bass. Then consider what there is to make noise. At ground level, winds are sluggish. In such dense air, even a few kilometers per hour feel like a slow current nudging at your suit, rather than a breeze on skin. No forests to hiss, no rivers to chatter, no insects to stitch the night with rhythm. The Venera craft that knelt briefly on those plains recorded what they could. The tapes did not bring back thunder or the hiss of rain. No rain lands there, but a subdued, continuous breath of wind moving across rock. A planet-sized seashell held to the ear. The hum is real, but it is the background, not a symphony. Silence here is not absence, it is suppression. The density swallows transients, softens percussive moments, and lets only the deeper vibrations roll far. Under that quiet, the stone still lives. Stress builds and releases. Without drifting plates, the crust does not grind like ours, but faults slip, and something akin to quakes, call them Venus quakes, likely pass through the ground. Orbiters have reported hints, subtle changes that look like rumble, translated into data. On Earth, quakes roar because air and structure amplify them. On Venus, a tremor would arrive as pressure felt in your bones and boots. A long, low growl underfoot, quickly swallowed back into stillness. Volcanoes write a part of the soundscape too. The maps say the planet is built by fire. The atmosphere says any roar will be hushed. On our world, fountains of lava crack and hiss as gas explodes into cooler air. On Venus, the gas would expand into a weight that resists quick motion. Eruptions, if you stood near one, would speak in heavy syllables, booms that spread like slow waves, a far-off drum again, not the spitting fireworks of a Strombolian show. The hiss becomes breath, the crack becomes pulse. Electrical storms may flash overhead, where the clouds are born and sustained. If they do, the lightning likely glows longer than our quick forks, its light stretched by the density and diffused into the haze, a pale illumination rather than a jagged line. Thunder would change its voice accordingly, less a snap than a pressure surge rolling without edges. You would feel it more than hear it, the way distant surf is felt as much in the ribs as in the ear. Even knowing the mechanisms, the effect is eerie to imagine. The horizon is close because the haze shortens sight. The sun is a pale coin struggling to pierce sulfurous veils. You stand impossibly protected and listen. Your own breath sounds large, deepened by the air, reverberating within your helmet. The world answers with a hum, a patient, steady tone. Now and then the tone swells as a passing current shifts or a slow, buried event moves through stone. Then it settles to its baseline, an unbroken presence, as if the planet were a single instrument holding one long note. All the while, the atmosphere thousands of meters above you races. Winds complete a lap of the world in a few days. Chemistry churns. Droplets of acid gather and fall and vanish before they touch rock. The oven is on. The quiet persists. It is a strange union. Violence contained by density into a hush. Activity made nearly inaudible by the medium that carries sound best. The silence is not emptiness. It is the result of conditions that keep most sounds from finding a shape. The past, if it was gentler, adds a melancholy shade to this quiet. If there were once seas, they would have had voices, waves on basalt shores, rain on lava fields, rivers gnawing at fresh rock. Those voices, if they existed, are gone with the water that made them. What remains is the low breath of an air too heavy for flutter, the dim music of rocks shifting under their own weight, and a sky that sometimes, perhaps, glows with silent lightning. Earth's music is different because Earth's balance is different. We wake to birds because air and leaf and light have made room for them. We hear rain because water can rise and fall and rise again. We listen to wind-comb fields because the atmosphere is light enough to play among grasses. The difference is not just distance from the sun, it's the set of feedbacks that caught us and kept us. Venus leans close and says, in its way, that the razor's edge is real. Our greenhouse is a hearth. Its greenhouse is a lock. Between them is a story about process, not punishment, about how oceans, rocks, air, and life cooperate to shelter or fail to. When your evening brings that bright point low in the west, there is more in it than shine. There is a physics lesson seen from your doorstep. The same molecules that make spring evenings mild can, in other quantities and contexts, make day and night equally fierce. There is a history tucked into a ratio of heavy hydrogen to light, a fingerprint of water lost. There is a forecast tucked into the logic of feedbacks, a gentle reminder that the levers we pull matter, that climate is a living system and not a painted backdrop. There is, too, a way of listening embedded in the thought. Listen to what atmosphere says about rock, to what chemistry says about light, to what silence says about motion. A planet can be loud in deed and quiet in sound. A sky can be beautiful and merciless. A twin can be nearly the same and end utterly different. In all of it is the nudge toward care, care with models, care with stories, care with the narrow arrangements that make our nights cool and our days bearable. The tale of the two greenhouses does not ask for fear, it asks for attention. Earth's blanket is the reason rivers run and lungs can rest. Venus's blanket is the reason metal softens on mountaintops. The line between them is thinner than it looks from far away, and it is drawn by details, by water held or lost, by cycles that run or stall, by feedbacks that calm or scream. Cherish is not a grand word here. It is a practical one. To cherish balance is to keep tending it. And if you picture the ancient sister as she might have been dim sun, soft clouds, seas flashing light back into the sky, let the feeling be both sweet and sober. Sweet because the universe may make habitable moments more often than we guess. Sober because those moments can pass. A world can sing and then fall quiet. A voice can be strong and then become a low hum. When you step outside and see the evening star, you are looking at both a present and a possibility that slipped away. The glow holds both, love and fire, balance and break, a beacon that teaches by being beautiful and by being true. Listening to a planet is not only poetry, it is method. The way sound travels, the way quiet lingers, the way a tremor turns from crack to murmur, all of it reveals how air and stone share their burdens. On Venus, those clues arrive half hidden. The dense carbon dioxide sky lowers every voice, favors bass over brightness, and blurs the edges of sudden events. Quakes become slow rolls that pass through rock like breath. Eruptions trade hiss and crackle for a heavy, distant thrum. The hush is not emptiness, it is compression, a soft weight laid over every vibration. When instruments are tuned to this language, microphones that prize low frequencies, seismometers patient enough to read pressure more than pitch patterns emerge, the silence becomes legible. A world that roars in chemistry but whispers in sound begins to explain itself. That quiet carries a second lesson. Geology can persist without the choreography of drifting plates. Venus lacks Earth's global jigsaw of slabs and seams, yet its interior still pushes, sags, and breathes heat into the crust. The signature of that motion is written in subdued tones in the way rifts stretch, in the slow settling of coronae, in winds that bear the burden of uniform warmth. Studying these muffled voices teaches us how planets express their inner work when the usual instruments, rivers, raindrops, and eroding winds are missing. The portrait that forms is strange and lovely, a place as compelling in its hush as in its fire, a furnace wrapped in velvet. The bright point at dusk invites a different kind of listening. Behind the glow sits a world wrapped in quiet. Sound bends low, eruptions are whispers. Dominance belongs to the low, steady register of a thick sky. It is a reminder that the cosmos often hides its loudest engines behind the softest surfaces, that the same planet that outshines every star at twilight can be nearly mute at the ground. After years in the shadow of red deserts and rover tracks, attention is tipping back toward this golden neighbor. New craft are being prepared with instruments gentle enough to catch faint signals and sharp enough to read through the veil. Names arrive like small poems: De Vinci, Veritas, and Vision. Each brings a different ear, a different eye, a different way of lifting meaning from glow and echo. One will fall through the air itself. Da Vinci, The deep atmosphere, Venus investigation of noble gases, chemistry, and imaging will ride a descent sphere into the layered sky. As it drops, it will taste noble gases that hold the memory of formation, count isotopes that tell stories of lost water, and map the changing chemistry from bright haze down toward the dark. Cameras will search for rare windows through the clouds, aiming at ancient highlands called tessera, jumbled, bright terrains that may be the oldest pages left unburned by lava's later edits. The end will be brief. The surface does not grant long visits, but a few lucid minutes pressure known, temperature confirmed, colors caught, could anchor decades of questions. Another will circle and sound the ground. Veritas Venus emissivity, radioscience, INSAR, topography, and spectroscopy will sweep the planet with radar sharper than the maps we've relied on since the 1990 seconds. Contours will come into focus at scales that let rifts, lava flows, and faulted blocks give up their timing and sequence. Thermal emissivity will hint at rock types and, perhaps, at places still warm with fresh stone. If changes are caught, new flows, shifted slopes, alterations in surface brightness, then the case for ongoing volcanism strengthens, and with it, a new way to link air and ground. Sulfur spikes above, black rock below, cause and effect stitched through cloud. A third will thread the picture together. Envision, from Europe, will pair radar and atmospheric study to watch how outgassing and weather talk to one another. It will linger over Coronae, inspect tessera mosaics, and track faults that cut plains into long, patient lines. Where Da Vinci tastes and Veritas measures relief and heat, and vision will compare, cross-calibrate, and follow changes over time. Together, the trio turns a once-distant lantern into a near neighbor with a readable diary. Curiosity is not the only engine. There is perspective here that loops home. Two planets of almost equal size began under the same sun and diverged. One learned balance, one locked into heat. To understand where the fork happened is to understand the boundaries of habitability, not in theory, but in practice. The greenhouse that keeps our nights soft is kin to the greenhouse that keeps Venus noon forever. The physics is the same. The outcomes depend on reservoirs, cycles, and thresholds. Refining models with data from a world that has taken the greenhouse to its limit feeds back into the forecasts we make for our own air and seas. It widens the caution without dulling the hope. There is also the simple romance of it, a probe falling through amber light, counting atoms older than continents, a radar glance revealing a ringed scar 1,000 kilometers wide, a spectrum that shows the breadth of a cloud droplet before it vanishes back into vapor. The veil has been patient and stubborn. Each mission that dares to pierce it feels like the quiet turning of a key. In these returns, there's a kind of redemption. For generations, Venus was dressed in fiction rainforests under clouds, swamp forests steaming with life. When the first numbers arrived, pressure like deep ocean, temperatures that soften lead disappointment stole some of the attention. The new story is harder and better. Venus is not a failed Earth. It is a necessary chapter in how rocky worlds work. Extremes are not deterrents here. They are instructions, written large enough to read from orbit. Answers will not arrive as a parade of headlines. They will collect like dew, a shift in sulfur here, a changed slope there, ratios in a noble gas that pin down how much water was truly lost. Tessera textures that refuse easy analogies and force new ideas about crust without plates. Each small clarity tightens the weave. Each detail feeds the larger picture. Whether the planet breathes fire now, how the crust bears stress, how the sky recycles its acid and heat, how long the uniform furnace has held. Perspective grows wider when Venus stands among its siblings. Mercury, bare and airless, bakes and freezes in extremes that alternate with the sun's rise and fall. It is hot because it cannot hold heat. Mars, small and leaky, kept rivers for a while, then let its air be stripped away. It is cold because it cannot keep what warmth it gets. Earth sits between, with oceans and plates, and life making long cycles that buffer change. Venus is the counterpoint, hot not from exposure, but from entrapment. Air not as weather, but as weight. Rotation slow and backward enough to give the sky its own independent race. 4 nearby worlds, 4 different answers to the same question. What does rock become under a star? This spectrum reaches beyond our system. When a distant dot dims its sun in transit and a telescope catches a whiff of its air, the habits learned from Venus matter. A high cloud deck bright in reflected light can mislead. Thick CO2 can hide behind beautiful albedo. The Venus zone, orbits that are close enough to tip planets into greenhouse lockdown, sits beside the more hopeful, habitable zone. Knowing which is which sharpens the search for oceans and softens the urge to declare each Earth-sized world a twin. If we are to read the spectra of other skies honestly, we must keep Venus's grammar near at hand. The same light that guided sailors and seeded myths now guides instruments. The morning star still rises, the evening star still lingers above rooftops, impossible to ignore. But behind the brightness is a planet that has taught us to be careful with first impressions. Beauty and danger walk together more often than we like to think. The veil that looks gentle is woven from acid. The calm uniformity is the mark of heat that never yields. The lesson isn't to turn away. It is to look with better eyes and listen with better ears. Hidden sounds make their way into that listening, too. A low rumble that betrays a fault slipping. A long, soft pressure wave from a distant eruption. A possible flicker of lightning translated into radio whistlers curling through the sky. These are not the loud spectacles of our weather. They are the muted bookkeeping of a heavy atmosphere doing its work. Learning to hear them is part of learning the planet. The family portrait at last feels complete enough to instruct. Mercury shows the cost of being bare. Mars shows the cost of being small. Earth shows the grace of balance when cycles are long and linked. Venus shows what happens when those cycles stall, and water vanishes when heat is kept as a policy rather than a passing mood. None of these worlds is lesser for failing to match our comfort. Each shows a different solution, a different answer whispered to the same star. Beneath culture's long devotion to Venus, the goddess, the poem, the bright companion, there is a newer devotion forming to the facts that refuse to be plain and to the patience required to gather them. The coming craft will not cure the planet of its heat or soften its air. They will do something better. They will listen and look with clarity, and they will bring back pieces that let us hold the whole more gently in mind. When the sky darkens and that unwavering light appears, imagine a descent capsule sliding through gold, counting noble gases as mile gives way to mile. Imagine a radar eye catching the fresh edge of a flow no one has ever seen. Imagine low microphones registering a pressure wave that began as a stone shifted far away. None of this will be loud. All of it will be true. The planet that outshines the night is calling again, not with thunder, but with steadiness. We are answering with careful instruments and humble questions. In the data will be echoes of seas that may have been, traces of fires that may still be, and a lesson about balance, so clear it feels like a lullaby. That warmth can be welcome or imprisoning. That silence can hide motion. That brightness can be both invitation and warning. Venus remains a mirror of myth, of physics, of our own responsibilities. And the clearest part of the reflection is this: even among twins, the line between comfort and calamity is thin, and listening closely is how we learn where it lies. Curiosity blooms in the places that push back. When Venus proved itself fierce, fascination didn't fade, it deepened. Two worlds born from the same whirl of dust and light, so close in size, so alike in ingredients, drifted apart until one kept oceans and the other kept heat. That riddle kept calling. We answered with machines built to endure minutes, not months. Soviet landers dropped through the oven and whispered a few frail words before falling silent. A patient radar eye traced slow loops and turned clouds transparent, sketching mountains and floodplains of stone. Soon, new craft will take their turns, one tasting the air as it falls, one sweeping the ground with finer sight, each a small, steady promise that mystery can be met with care. It isn't only a map we're making, it's a mirror. In Venus, we see the stubbornness of matter and the tenderness of balance. A little more sunlight, a little less water, a little less traffic between rock and air, and a planet can tip from tempered warmth to relentless heat. That thin line is not dramatics. It is physics carried to conclusion. The oceans and forests that cradle us here are not ornaments. They are threads in the loom. Tug them carelessly, and the pattern changes. Some changes can be rewoven, some cannot. Venus does not scold, it shows. Humility grew alongside the data. For centuries, we filled that shining lantern with jungles and rain and the comfort of mirrors. Then the first numbers arrived, pressures like deep seas, temperatures that soften metal, air thick with acid haze, and the story turned. Wonder did not end, it sharpened. The universe owes us nothing, and yet it lets us learn. The evening star remained beautiful. It simply asked for a new kind of awe, one that makes room for both poetry and proof. Perhaps that's why the planet keeps its hold on the imagination. It gathers opposites and lets them sit close without noise. Beauty and burden, hope and warning, romance and rigor. To look at Venus is to look at our own doubleness, drawn to brightness, tested by truth, fragile and yet persistent enough to keep reaching. A goddess of love, yes, and a furnace hidden in daylight, a jewel and a veil. Not contradiction, but wholeness. Constancy gives the lesson a home. Generations have watched that light lean into dusk or rise before dawn. Shepherds and sailors, poets and mathematicians, children with sticky hands and tired eyes, all have caught the same gleam. Empires fell. The star arrived on time. Music changed. The star arrived on time. We paved the ground and lifted towers. The star arrived on time. That steadiness is part of its power. The heavens continue while our stories turn over. To share a view with ancestors is to feel time soften. To learn the truth under that view is to feel time deepen. And the truth is layered. Behind serenity lies a landscape where air weighs like water, where clouds are laced with acid, where rock remembers oceans not by sight, but by absence. Winds race high above a ground that barely turns. Lightning, if it lives there, writes in slow, diffused flashes. Mountains glint with metallic frost. The sky sprints. The stone lingers. Sound drops into bass and stays. It is a world that hides its movement in hush, a place that speaks softly even when the forces are strong. The contrast is not a trick. It's the rule book of another home. That other home has already taught us to read distant ones. When telescopes catch the breath of exoplanets, the grammar we learned from Venus keeps us honest. A world the same size as Earth and close to its star is not automatically a harbor. Clouds can be bright and unkind. Carbon dioxide can be both blanket and lock. There is a place in each star's neighborhood where oceans are possible, and another where warmth outruns mercy. Naming both helps us find what we're seeking without telling ourselves a story too soon. Still, we return, because returning is what we do. A descent sphere will count noble gases that remember the beginning and weigh water's ghost in the pattern of heavy and light hydrogen. A radar craft will look for new edges on old flows and for the heat of rock too young to cool. Another will braid air and ground into a single tail, following the path from vent to cloud to light. None will stay long. None needs to. A few clean notes can carry far if the instrument is tuned. What Venus also gives is scale of risk, of patience, of care. It reminds us that resilience is more than survival. It is the practice of learning while we endure. Those first landers lasted minutes and changed the story forever. The next will last hours and change the questions. We are small on the measure of planets, smaller still on the measure of stars, and yet we send out hands made of metal and logic and trust. They fail, and we build better. They succeed, and we ask harder things. That rhythm is our own kind of weather. Set Venus among its siblings, and the lesson rounds out. One world is bare and blinding, hot at noon and freezing by night because nothing holds. Another is thin and quiet, having lost its air and most of its warmth to space. Ours keeps an even breath because water and stone and life trade energies and elements with long, unshowy discipline. The fourth keeps heat as a policy, spreads it evenly, and chooses constancy over comfort. 4 answers to the same star, 4 ways of being a world. If we love one answer most, it's because we live inside it. But the others are not mistakes. They are variations, each a proof that small beginnings can flower into very different ends. And still the light is lovely. That may be the most human part of the story. Knowledge did not strip away the moment when the evening star first arrives and the day doesn't want to yield. If anything, it added a kind of tenderness. We can hold the image of volcanic plains wider than countries and winds circling a globe in days and still enjoy the simple brightness above the roofline. Mystery and understanding are not enemies. They take turns. Some nights belong to questions, some to quiet, most to both. When you step outside and see the planet bright against the thin blue or the new dark, let a small ritual unfold. Think of minutes borrowed by brave machines. Think of maps drawn by echoes. Think of clouds that gleam like silk and bite like fire. Think of oceans that may have been and of hydrogen that left and told on them. Think of a sky that runs while the ground shrugs. Then let those thoughts loosen. Let the light be only light for a while. Somewhere, Engineers are soldering, testing, packing instruments into shells meant to meet impossible numbers with calm. Somewhere, a team is practicing words they will speak when the signal drops and returns as data that no one has ever seen before. Somewhere, a child is asking why that star is so bright, and someone is saying its name with a smile. The chain is unbroken. Question, attempt, correction, surprise, care. Venus keeps its appointment in the sky. We keep ours on the ground.